Welcome friends, I am Vibhas Tarfe. Today I am going to talk about the sample and hold amplifier. Let us see the contents of the seminar. We will quickly go through the introduction, then we will see the historical development of the sample and hold circuitry. We will see the sample and hold circuitry is a functional block of the sample and hold circuitry. Its working, the number of modes in which sample and hold circuit is actually working. Then we will see the acquisition time, which is the most important parameter for the sample and hold amplifier. Then some of the application of the sample and hold amplifier. Let us start with the introduction. Sample and hold amplifier is the most important part in the data acquisition system, and it is commonly used in the analog to digital converter. Just before the analog to digital converter, we can see the sample and hold circuitry. As we know that ADC is most integral part of the data acquisition system. Nowadays, the sample and hold circuitry has become the one of the major important part of the data acquisition system. The sample and hold amplifier was first introduced by the A.H. Reeves. He has used this sample and hold amplifier in PCM. In his PCM patent, which was patented in the 1939. It was actually 5-bit 6 kilo sample per second counting ADC. In 1948, after that, Bell Labs introduced the 15 kilo samples per second ADC. Then the researchers in the semiconductor field introduces the transistors and FETs, which greatly improves this field. Nowadays, we can find the sample and hold circuitry which can support up to the 16-bit ADC and have the speed of 12 mega samples per second, more than 12 mega samples per second. Sample and hold circuitry, as I told you, sample and hold circuitry is the building block of the ADC. The sample and hold circuitry is used just before the ADC circuitry. What are the main components of the ADC? The input amplifier, energy storage device, that is now we use as a capacitor, then output buffer, and the switching circuitry. This is a basic circuit diagram for the sample and hold circuitry. We can see this is a input amplifier, then the switch, and the output buffer. This is a storage device, which is a capacitor. Normally we use as a capacitor. The switch can be anything, that the CMOS, FET, diode bridge, or bipolar. Any semiconductor device we can use. For the switching this switch, we are using the switch driver. The input amplifier. The input amplifier is used just before the. It is a input part of the circuitry. It provides a high impedance for the signal source. What are the signal source we are connecting to the sample and hold amplifier? It provides a high impedance, as well as it gives a high current gain, so that the capacitor can charge easily. Energy storage device. Normally we are using the capacitor in the sample and hold circuitry as an energy storage device. It is a main integral part of the sample and hold amplifier. We can say it is the heart of the sample and hold amplifier. It holds the sampled voltage of the input source for the some time period. In ADC, it holds that voltage for the until the conversion ends. In output buffer. Output buffer offers the high high output impedance for the circuitry. Actually, this high output impedance is prevents the discharging of the capacitor in the whole mode of the circuitry. In switching circuitry, switching circuit is a mechanism which is used for the switching the sample and hold amplifier from the sample mode to the hold mode, and hold mode to again back to the sample mode. Normally, we are using the semiconductor switches for this purpose. The semiconductor switches are used as a FET, CMOS, or BJT, and these switches are controlled by the switch driver. Normally, as a switch driver, we are using the controller. Then we will start working. First, we will see the sample mode. This is a sample mode. In sample mode, the switch is closed. You can see the switch is closed, so that the circuitry at the short circuitry, whatever the input we are giving in the analog input side, it get amplified through the input amplifier, and the amplified circuitry amplified signal is directly fed to the capacitor. Capacitor get charged from this in the sample mode from the supply whatever we are supply. The in sample mode, the input this is the input amplifier. It acts as a normal amplifier. It passes the whatever the signal it is having at the input side, it passes to the capacitor, and capacitor will get charged to the level as the same as the analog input supplied to the circuitry. In hold mode, the switch driver opens the circuit. When the switch driver gets open the circuit, the circuitry acts as a open circuit. The no input supply can pass through the switch to the capacitor, so that capacitor will not get any extra input from the input supply. Whatever the supply it has provided in the sample mode, it is already charged to that level and holds that charge till the conversion takes place. As I told you, this analog output stage has a high input impedance, so that it will not get discharged from this circuitry very easily, as it has a high output impedance. Then we will see the modes of operation of the sample and hold amplifier. That was the basic working of the circuitry. Normally sample and hold amplifier operates in the 4 modes. Track mode is also called as the sample mode. Track to hold mode, sample to hold transition mode, then hold mode, and hold to track transition mode. Actually the sample mode and hold mode are divided into 4 different operations. Let us see the sample mode. In sample mode, we have seen that the switch get closed, so that it acts as a short circuit, so that the whole circuitry we can if we can see that it acts as a normal amplifier. So what are the input it is getting, it is directly passed to the output of the amplifier with small DC offset voltage. That is the amplification of the signal. And in this sample mode, as this acts as a normal amplifier, it shows the all properties of the all the static and dynamic properties of the amplifier. In track to hold mode, track to hold mode is the actual transition when sample the circuitry is in a sample mode and is transition to the hold mode. Due to the transition, the small transient is occur in the circuitry, so that it is because of the all switches we are using. This is not ideal. Even though we are using the semiconductor switches, it has some internal construction properties. So because of that, it cannot act as the ideal switch. So it provides some transients in the switching. Because of that transients, it produces DC voltage for the charging of the capacitor. That is called the pedestal error. This is a waveform. We can see this is a hold signal, hold command signal. When we supply the hold command signal, the output gets hold, and it try to be in a steady state level, and it remains to the some height extra DC offset voltage than the regular one. This is the actual where the sample should be hold at this line, but it has some DC voltage. We can see this is the DC voltage, extra DC voltage offset. You can see which is added. This is called a pedestal error. Hold mode. Hold mode is a mode in which the circuitry is try to hold the voltage at a particular level, or the level at which the signal has sampled to. So the capacitor is main important part in this thing, because it stores the charge and try to be at that sample only till the whole till the conversion ends. But sometimes because of imperfection in the construction of the capacitor will discharge slowly. It has because of some leakage current. This discharging or this error occurs is called as a droop error. We can see this is a waveform. The when the this is the instant at which the capacitor will get charged. From this instant, it will discharge slowly. It will not discharge quickly as we have supplied the high output impedance, but it will discharge because of the leakage current which is present. So the level will get dropped, and at the final of the end of the conversion, we will see that the some deflection from the main voltage level to the actual voltage level. This is called as a droop error, and the rate at which the voltage is going down is called as a droop rate. Acquisition time. Acquisition time is the most important parameter, or the most important parameter or property of the sample and hold amplifier. Actually, it is the ability to connect and disconnect the whole capacitor from the input buffer. What are the input circuitry we are seeing, which is connected and disconnected to the switch. The ability or how quickly the circuit can switch from the sample mode to hold mode is called it is actually defined by the acquisition time. What are the time taken for this transition from the sample mode to hold mode, or hold mode to sample mode? Is this time period is called as the acquisition time. It is, which is a very short time, but we cannot say it is a zero time interval. It is some non-zero short time interval. Applications. As I told you, this is the most integral part of the ADC, or analog to digital converter. During the analog to digital converter, we require to sample the voltage. What are the voltage input circuitry we are converting, analog input circuitry we are converting to the giving to the ADC. We have to sample it. So for sampling that signal, we are using the ADC sample and hold circuitry. Sample and hold circuitry for sample this voltage, means peaks the voltage at the time instant, and hold circuitry hold that whatever that voltage has peaked by the sample circuit at that instant. It is held by the hold circuitry. Hold circuitry holds until the ADC completes its conversion from the analog to digital converter. As we have seen the we have seen the different types of ADCs used for conversion of ADC analog signal to the digital signal. The ADC required constant voltage at that particular instant. Means for the conversion particular conversion time, it requires a constant voltage at the input side. So that constant voltage is provided by the hold circuitry as a hold hold the input voltage for the some time for the conversion. Also for sometimes we have to sample the voltage for more than one time. Actually, as in the ADC, we have to sample the same voltage for the at a particular time instant. So we are using the sample and hold circuitry in that. Mainly the sample and hold amplifier is designed and developed for the ADC. This was the presentation for the sample and hold amplifier. Hope this was useful for you. Thank you for watching.